silly. I want to start off by congratulating you. Level 2 was probably not easy, and no doubt you ran into code bugs and build issues that made your eyes bleed. Here's the thing, at any point, you could have quit or walked away, but you didn't. That means there's something in ya, a hunger, a drive to keep pushing. I'm gonna let you in on a little secret. That's all it takes to get really, really good at this stuff. So let's go further than we ever have before. Welcome to level 3 coding. I'm very excited for this. So let's just jump right into it. Okay, so you're home for level 3 code, aka the IDE you'll be using, aka the place where your code gets written and uploaded to the Arduino. It's called Eclipse. Eclipse is open source and free and mad litty. Pull up. Now, if you're a rogue robot trainer who's not in Nerdy Girls, I'll have a how to set up Eclipse for level 3 tutorial linked in the descrizzle. If you are in Nerdy Girls, just keep watching for some sweet, sweet instructions. But first step, open up Eclipse. It should ask you if you want to use a workspace called Eclipse-workspace, and to that you should say okay. A workspace is just a folder on your computer where all of your code projects live. If the workspace looks like this, hit restore to restore the layout of Eclipse. Next, you need to make sure that Eclipse has what it needs to program the Arduino Mega 2560 board that is our brain. Go to Help, then Arduino Downloads Manager, and make sure you have the Arduino AVR board's platform installed. If you don't see that here, hit Add, and then click on it to add it. It's time to make our very first Arduino project in Eclipse. Click on File, then New, then Arduino Project. Select the Arduino C/C++ sketch, then name the project. I'm gonna call mine Dark Rider Navigation. Make sure Use Default Location is checked and click Finish. Finally, we need to tell Eclipse where to download the code when the time comes. So let's open up Device Manager, then plug in the Arduino, and then we can find the specific name of the communication port or COM port we just plugged into. Okay, so it looks like it's COM port 5. Very special and exclusive COM port only for cool kids. Click on the Launch Target tab and then hit New Launch Target. Click Arduino and then come up with a very special name that you'll associate with this particular Arduino board. I'm calling mine Mega Awesome. So pick the COM port that we know is associated with the Arduino, pick the board type, which we know is a Mega 2560. Then hit Finish and make sure it's selected as the active launch target so that Eclipse can communicate with your particular board through this particular COM port. We're ready to start writing some code. So if you recall, we have some wires going from the motor driver to the Arduino. So first thing we need to do in the code is tell the Arduino what's up with the motor driver. We have 6 pins that we care about on the Arduino. 2, 3, 4, 5, 6, and 7. 2, 3, and 4 will control the left motor, and 5, 6, and 7 will control the right motor. Here's the deal. Trying to remember which port number is responsible for what as you're writing the code is just asking for trouble. So instead, we're going to give each of the pins a name so that we can use that name in our code instead of the pin number itself. Byte, left motor 1 equals 2 semicolon. So what does this line do? This might be familiar. It declares a variable called left motor 1. And remember, a variable is just a little storage container for a value. And this storage container is being assigned a value to store, which in this case is pin 2. So whenever we use the name left motor 1 in our code, it knows that we're talking about 2 because that's what left motor 1 stores. The byte specifies that this variable is of the data type called byte, which can store numbers 0 to 255. Perfect for a pin number. Byte is one of a bunch of different data types that you can use in your program. By the way, you can zoom into your code by holding down Control and Shift and then hitting the plus sign. You can zoom out by holding Control and hitting the minus sign. I'm gonna copy and paste this 5 more times for all of the pins we're using, except we need to rename them. We need an input 1 pin, an input 2 pin, and a PWM for each drivetrain motor. So I'll do left motor 1, left motor 2, left PWM, right motor 1, right motor 2, and right PWM. And then we need to change the assigned values so that they're 2 through 7. Make sure all of this is up here outside of the setup function. If you were to put this inside of the setup function, the names that we gave the ports would only apply to the setup function, and we'd get errors if we tried to use any of the names anywhere outside of the setup function. We need it up here so that its scope is global, baby, so that we can use the names of our pins in any part of the program. Next, inside of setup, we need to tell the Arduino that these pins are output pins. Pins can be either input or output. If, say, a button was plugged into one of these pins, we'd want that pin to be an input because pressing that button is sending input to the Arduino. But we want these pins to be output because the Arduino is sending commands in the code, like motor power, out through those pins to our motor driver. To tell the Arduino that these pins are output pins, we need to call a function from the Arduino library called pin mode, parentheses, semicolon. In order to make pin mode work, we need to pass 2 pieces of information or 2 arguments to it. First, the pin, so I'll do left motor 1, comma, and what type of pin it is, so output. I'll do this for each of the pins up here. Comment checkpoint. Make sure everything's well commented so you and other coders can easily grasp what everything does. For the motor driver that we're using, there are 2 steps to making a motor move. 1, give it a direction, and 2, give it a PWM signal. Step 1, how do you say what direction you want it to move? Am I right? Remember how there's a pin 1 and a pin 2 for each motor? Well, if we set one of those pins to high, aka open it up to 5 volts of electricity, and the other to low, aka send 0 volts, the motor will be set up to spin one direction. If you reverse which pin is high and which pin is low, the motor will be set up to spin in the opposite direction. Let's test this right now. Make sure your robot is blocked up so that when it moves, it doesn't yeet itself into the void. I'll test the left side first. To set a pin to high, I'll use the digital right function, which takes whichever pin we're talking about, in this case left motor 1, and whether you want it high or low, and I want it high. Then we'll do the same command for left motor 2, except we want it low. Next we have to give it a PWM signal. We're going to use the analog right function and pass to it the PWM pin that we're talking about, left PWM for me, and the PWM wave value, which ranges from 0 to 255. So we talked about what PWM is in the last tutorial, link in the description. If the idea of how PWM signals work is confusing you, for now just think about this range as determining power. 0 is no power, 255 is full power. So now that we got the motor spinning, we need to tell it how long to spin for. I'll use the delay function and pass to it how many milliseconds I want to wait for. I'll do 1000 or 1 second, and we need to set the PWM signal to 0 in order to stop the motor. I'm putting all of this in the setup function because all the code in here is executed only once when the code is first run. I only put stuff in the loop function that I want to have happen over and over and over again, like a loop. Let's make sure our code is bug-free by saving it, that's Control and S, and building it, which compiles the code. If your console log looks like this, then your code is healthy and thriving. If you type something incorrectly, Eclipse will say, "Hey buddy, there's a syntax error here and I don't like it." To test the code, I'll plug in the Arduino board to the computer with the robot off. If I wanted the code to run immediately after downloading, I could keep the robot on, but this is a safer bet. Let's run the code, aka download it to the brain. Once Averdo is done, and thanks you're welcome, unplug your robot and flip it on. Now my left side is spinning backwards, and I can change the wiring, but I prefer to change directions in the code. I'm gonna try swapping which pins are high and low, and I'm gonna rebuild and download, and boom, it's spinning forward. If your robot's wired correctly, making the opposite pin high on the right side should also make it spin forward. Right motor 1 high, right motor 2 low, give it some power, and then set to 0 after 1 second. Okay, now the robot moves forward for 1 second. One thing I like to do is once I've figured out which pin on each side makes the robot go forward, I like to rename the variables to left motor forward and right motor forward, or FWD. And I'll rename the ones that are currently driven low, left motor back, and right motor back. So now I know that if I drive the forward pins high and keep the backward pins low, the robot will go forward, and I don't have to keep track of whether pin 1 or pin 2 is the one that I want. Now what about turning? My thoughts exactly. Well, let's copy and paste what I have here and just swap the high and low pins on one side so that now the backward pin is high and the forward pin is low. How long the turn lasts depends on how long your delay is for that drivetrain. And let's add a little delay in between the steps to space them out a little bit. Boom! We got a forward and a turn, baby!
Comment checkpoint.
So when it comes to conquering Rainbow Road, you could just keep copying and pasting these chunks of code to navigate yourself through. But I'm going to take my code a step further. And just like in level 2, I'm going to make special little functions for going forward and turning so that when I want my robot to do those things, all I have to do is call those functions and specify how long I want the robot to do that for. Let's do this. First thing that we have to do to make our functions, aka our precious little boxes of commands that we can call up, is tell the code that, hey, there are functions in this code. Don't worry about it. At the top, we're making our forward declaration. Don't worry about the void right now. Then the name of the function, I'm doing go forward, and parentheses semicolon. Let's start by defining or building out our go forward function at the bottom of the code. Let's copy and paste the going forward chunk that we have up here and paste it into the function. And I'll delete the movement code we haven't set up so far. Technically, this function works, and if I were to call it and set up, the robot would move forward for 1 second. But what if I need to go forward for lots of different lengths of time? What if I need to go forward for 1 second in one part of Rainbow Road and then half a second in another part? I can actually use this one function for all the different drive times that we need, but first we need to tweak it. First thing, up here in the forward declaration, we need to declare a variable inside these parentheses that will belong to the function. It's called a parameter, but don't worry about the terminology right now. I'm calling this variable time, and I'm making it of type integer, which stores whole numbers, and it can store way bigger numbers than byte. Then in the function down below, we also need to declare that variable in the parentheses. So now the function knows, okay, I have this variable called time. Right now the robot drives forward for 1000 milliseconds, but well, what if we replace the 1000 with our time variable, huh? Now, the robot drives not for 1000 milliseconds, but for whatever number of milliseconds is assigned to or is stored inside our variable. So the last step is, how do we assign to this function a number for the time variable? Well, since we declared time here in the parentheses of the function, that means that the function expects to be given a value for time. So when we call the function, we just need to give it the number of milliseconds that we want the time variable to store. I'll say 2000 here. Now when I call this function in setup, the code sees that I've called it, jumps down here and says, oh, there's a variable. What did the coder want me to store in it? I gotta know. Oh yes, the number 2000. Then it runs through its routine, sets pins to high, sets PWM, delay. Oh, there's that variable again. Let me plug in what's stored inside of it. 2000. Then it finishes up and jumps back to where it left off in setup. I could then call the function again and assign a new value for time. 200 milliseconds, 5000 milliseconds, you name it. And look at how clean and short this code is, instead of copying and pasting over and over again like some sort of pleb. I also want a function for turning left. In this rainbow road, all the turns are left turns. So I'm gonna also declare a function up here called turn left. And just like go forward, we also want a parameter variable to hold the amount of time to turn for. I'll call that variable turn time. Why not? And to keep things super clear, I'll rename this variable drive time everywhere else it pops up. Okay, so defining the function down here, telling it again that we have a special variable called turn time. And the actual contents of the function are the exact same as the contents of the go forward function, except our variable is called turn time, and we need to make the left side go backwards to make it turn left, which we can do by swapping which pin is high and which is low.
Let's do a little comment catch up.
Setup, I'm going to run a quick test. Let's say I want to go forward for 1 second and turn for half a second, and I'll call the functions and pass to them the times that I want. And in between the robot doing each of these commands, I like to give it a little breather break of maybe 100 millisecond delay, then build and download. It looks great, am I right? Now it's up to you to figure out the lengths of time you want to go forward and the lengths of time you need to turn to get that crisp 90. And as a PS, if you want to go really deep with the code, we're planning on making a tutorial where you implement an algorithm called PID to make your robot navigate insanely well. I'll have that linked in the description, so check for it if you want to do that.
It's battle time. The name of the game is to beat the Notorious Robot Challenge course, Rainbow Road. And now the final step is to immortalize your code. Give it to the world for all to see and use. Time to push Dark Rider's code to GitHub. First step is to get this project under Git's control. So open Git Bash. And if this stuff isn't ringing a bell, go back and watch the Git and GitHub setup video that I will have linked in the description. And step number 1 is to make a Git repository. All a repository is a code project folder that is under Git's control, meaning Git will track changes to it and will let you collaborate with other coders on it. Now to initialize a repository for our Dark Rider navigation code, we first need to tell Git Bash to open the folder where the code lives. So we're going to type cd, aka change directory, and the easiest way to direct it to our project folder is actually to just find it in the Explorer. So we're going to go PC, C drive, users, and then whatever your username is, and then you should find the Eclipse workspace folder, and then the project folder. Then we're going to drag that path into the terminal, and it'll automatically paste the path to the folder for you. And then when we hit enter, you'll see we are now working inside of the Dark Rider project folder. And that way, all the commands we type are gonna only apply to this folder. Real quick, we're gonna confirm that this project folder is not already a Git repository by typing git space status. We're gonna get a fatal error, which means that it still needs to be turned into a repository. Perfect, that's what we're about to do. To initialize a Git repository in this folder, we are going to type git space init, and boom. Okay, so now let's type git space status again. All right, let's see what's up. So you can see that everything inside that project folder is red. That means that Git sees these files, but it's not tracking changes to them. It's not under Git's control yet. So in order to get our code onto GitHub for the world to see, we first need to get Git to manage these code files. All right, so actually only 3 of these files we need to add to Git. We're gonna do Dark Rider Navigation CPP, which is the actual code that you just wrote, and then .cproject and .project, because those are extra files that's gonna let someone else take the project and dump it into their Eclipse. If you have a .settings folder, you can add that too, but we don't have one here, so I'm finna not worry about it. All right, let's add these to the repository. So to do this, we're gonna type git space add space and then the name of the file. I'm gonna start with the actual Dark Rider navigation code. So Dark Rider Navigation.cpp. Gonna hit enter, and then I'm gonna hit the up arrow to access that old command. Repeat this command with the .project and .cproject. Now let's run git stats again so we can see what's up. All right, so the files are in green, awesome, except they're not quite under Git's control yet. By adding them, we're basically queuing them up to be committed to the Git repository. We still need to pull the final trigger and commit them to the Git repository. To do that, the command is git space commit space -m, and then you can add a comment alongside your commit. So I'm gonna do first commit, hell yeah. You should always add a silly little comment when you're committing something new, and then we're gonna hit enter. Now they're committed. So now they're on Git, and we gotta add them to GitHub. To do that, we need to create a separate repository on GitHub that we can push our Git repository files to. So log into your GitHub account, we're gonna click new repository, and you can name it whatever you want. I'm naming mine Dark Rider Navigation. Just notice that they put dashes in for spaces. Do not initialize with a README. We can do that later on. Let's click create repository. And as of right now, this repository is a desolate wasteland with nothing in it, but we can change that. So we gotta copy this special URL for this repository. You're gonna go back to git bash and type git space remote space add space origin. Then you are going to paste the link you just copied. This is gonna link the Git repository to the GitHub repository that we just created. Okay, so finally we need to take everything in the Git repository and push it to the GitHub repository. To do that, you're gonna type git space push space origin space master. And at this point, it should prompt you to log into your GitHub account. And this should be the only time it does that. Let it do its thing, let it do its thing. Then you're gonna refresh your GitHub repo, short for repository, and whoa, our files are safely plopped there. So check it out, the code's right here, that's freaking awesome. Okay, so now the whole world can see, test, improve, fork, more on that later, your code. You just contributed to the open source community. Plus, this is now on your profile, making you a legit coder. Okay, and then for best practice, I like to add a README file to the repository. That's gonna act as like a description of your code to people on GitHub. So let's type up a jolly description. I'm just gonna make it the same as the description I added to the repository earlier. And since this is committing a new change to the GitHub repository, I'm gonna leave a comment along with this change that says, this change to the repository was to make a README. So that was a huge gulp of knowledge. Just let yourself get used to the words and the process. In some of these upcoming projects in level 3, I'll show you how to make changes to your code from the GitHub end and sync it with your Git or pull it into your Git repository, and how to make changes from the Eclipse end and push it to GitHub. Also, I'm self-taught, so if you see improvements, please leave them in the comments down below. But until then, remember to fear no algorithm. Peace out.